What is going on, guys? And I'm back again with another video. So in this video we want to talk about le raisonnement direct. So we've already talked about le raisonnement par contraposé. In this video we want to talk about le raisonnement direct. Okay, so now this is based on one important tautology or on one important proposition. So it is the proposition that P and P implies Q. Well, this is going to imply Q. All right, so this is based on this tautology or on this proposition. So now, what logic is here? So basically, we have that if P is true, we have that if P is true, or we can say vrai. So if P is true, and if P is true and the implication P implies Q is true, alors forcément or necessarily the proposition Q has to be true. Then Q has to be true. There is no other way. So if the proposition P is true and the implication P implies Q is true, then Q has to be true. So basically what we do is we suppose that the proposition P is true. We try to show that the proposition P implies Q is also true. Then we conclude that Q has to be a proposition that is also true. So this is going to be the logic behind this. So if P is true and the implication P implies Q is true, then the proposition Q has to be true. Now let me give you guys an example to help you understand. Okay, to help you guys understand, I'll give you an example. All right, now take care of this top part. All right, I'll take care of this top part. Or basically you can just take care of everything. And let's look at our example. So let R, not this R, this is for denoting the set of real numbers. Let's say R. So R is the proposition that quel que soit, for all values of n in the set of integers, we have that 16n squared. We have that 16n squared minus 48 plus 33. We have that 16n squared minus 48 plus 33 is actually going to be, well, to simplify this problem, we can say for all values of n in the set of natural numbers, we have that 16 n squared minus 48 plus 33 is a positive natural number, or is a positive integer. We can say is a positive integer, is a positive integer. All right, so for every n in the set of natural numbers, we have that 16n squared minus 48 plus 33 is a positive integer. So basically what we try to do is we suppose that n is an integer. So we suppose that the n that we're taking into consideration is an integer. So our hypothesis is that n is an integer, or we take n as an integer. Well, whenever we are talking about these is a natural number, sorry, not an integer but a natural number. Or whenever we are talking about natural numbers, we have that maybe the sum, or maybe let's say when we're talking about integers, the sum of integers is an integer, the product is an integer, and we basically have all those properties given to us by virtue of us taking n as an integer. Even for natural numbers, if you add any two natural numbers, we are going to have an integer. But if you subtract, for example, well, it might not be, you get out of the set of natural numbers. So let's just take natural numbers, and let's just consider the addition. And our goal will be to establish that for n, let n be a natural number, and let 6n squared minus 48 plus 33 be a positive integer. So that is going to be our hypothesis, is that n is a natural number. Now let me say n is a natural, n is a natural number, so it is in the set of natural numbers. All right, I hope that is clear. And then our goal is to show that P implies Q is a true proposition. Then our conclusion is that, having shown that P implies Q is true, our conclusion would be that Q is true. So this is going to be our logic. So this is going to be the way we're going to proceed. Okay, we've taken n as an integer. Now, when you have a quadratic expression, it is best to write it into its canonic form. Now, you basically complete the square. You use the complete. You write it. You write it in its canonic form by completing the square. Now, I'm not going to do that in this video. But if you want to complete the square, you basically first of all have to factorize by a. In this case, you factorize by 16, and then you basically look at half of b, and with a little bit of algebraic manipulation, you are going to find this result. So for now, we're just going to admit this result, and I'm sure you guys will be able to to solve this problem easily. So this 16n squared minus 48 plus 33 written into its canonical form is going to be the expression 4 and then 2n minus 3 squared minus 3. Now our goal will be to study now, is this number that we have on the right hand side positive or is it negative? So if it is positive, then P implies Q is true, because we've taken n as our natural number, and we've shown, or actually here we're supposed to have n, and here we're supposed to have n, so that we have that nice flow. So if this is positive, then the proposition P implies Q is true. So the proposition P will be true, and the proposition P implies Q will be, if it's true, then Q is also going to be what? Q is also going to be true. Now, is this positive that we have here? So, well, this number, I'll start with this number, 2n minus 3 squared. This number 2n minus 3 squared is greater than or equal to 1. Now, is this true or false? So now this is going to be true for all values of n in the set of natural numbers. Now, if you guys have doubts whether this is true or not, you basically, the set of natural numbers is 0, 1, 2, 3, and you can go on and on. So if you plug in 0 here, what are you going to have? You have minus 3. Minus 3 raised to the power of 2 is going to be what? It's going to be 6, which is going to be, it's going to be 9, which is positive. All right, so that is greater than or equal to 1. All right, that is greater than or equal to 1. If you get a 1 here, you substitute here, you're going to have what? 2 multiplied by 1 is what? It will be 2. 2 minus 3 is going to be minus 1. Minus 1 squared is going to be 1. So we have equality when n is equal to 1. And then for the other cases, we have that this is going to be strictly greater than 1. So this is true. This that we have here is true. Therefore, this is going to be positive. So if it is greater than 1, then it's going to be positive. So multiplying this by if I multiply by 4 on both sides of this inequality, what am I going to have? If I multiply by 4 on both sides, I'm going to have 4 2n minus 3 squared is greater than or equal to 4. Now, this implies that this that I have here, the 4 factor of 2n minus 3 squared is also positive because it's greater than 4, which is a positive number. All right. Now, if I subtract 3 on both sides, so I'm trying to construct this. So if I subtract by 3, I'm going to have 4 2n minus 3 squared greater than or equal to. Now 4 minus 3 is what? Is 1. So we have that this is what? Minus 3 here. There's because I'm subtracting 3 on both sides of the inequality. So 2n minus 3 squared minus 3 is greater than 1. So if it's greater than 1, well, it has to be positive. So this implies that this shows that P implies Q is what? Is true. Therefore, P is true. Then the n that we took was a natural number. P is true. All right. P is true. P is true. P is true. That is good. That looks great. P is true. That we have. Then we've shown that P implies Q is true. Now the conclusion is going to be that Q is also going to be what? True. There is no other possibility. If P is true and P implies Q is true, then Q has to be true. Now, because this is going to be an integer, because, well, we know that the set of natural numbers is a subset. The set of natural numbers is also going to be a subset of the set of integers. So basically, we are talking about the set of integers, not the set of real numbers. Well, this is actually true, but we are just talking about natural numbers and integers. So I just wanted to make sure that I simplify this problem for you guys to understand. So that is le raisonnement direct. So if P is true and P implies Q is true, then the conclusion is immediate. It is going to be that Q is going to be also Q is also going to be true. Thank you guys for watching, and I'll see you in the next video.